Okay, so there is this part over here as well, which is called the Miscellaneous Examples, and it's just a couple of exercises, examples basically, and the derivative of them. So for example, let's say that you have this function as f of x is equal to, for example, 2x plus 3 over x minus 2. Okay, now this function is basically f of x is not defined at x is equal to 2. At x is equal to 2, your denominator becomes 0. So your function is not defined there. And you want to find the derivative of you want to find f d by dx of f of x from the first principle. Okay. Now, based on the first principle, we said that f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. So now over here we have basically your function is f of x is equal to 2x plus 3 over x minus 2, and so f of x plus h is equal to 2 times x plus h plus 3 over x plus h minus 2, and so f prime of x is equal to the limit of f of x plus h, which is this thing over here, 2 times x plus h plus 3 divided by x plus h minus 2 minus f of x, which is basically this function over here, 2x plus 3 over x minus 2 over h as h tends to 0. Okay. Now this is equal to 2x plus 2h plus 3 times, okay, so now we just need to simplify this and see what happens. So the limit of basically x plus h minus 2 times x minus 2, and then that is basically that is basically 2x plus 2h. Let me simplify this a little bit. So over here, the numerator, I have 2x plus h, 2 times x plus h plus 3 over x plus h minus 2, and over here I have 2x plus 3 over x minus 2, and that is equal to x plus h minus 2 times x minus 2, and then over here I have 2x plus 2h plus 3 I have 2x plus 2h plus 3 over x plus h minus 2 minus x minus 2, 2x plus 3, and then this is equal to x plus h minus 2 times x minus 2, and then that is x minus 2 times 2x plus 2h plus 3 minus 2x plus 3 times this thing over here, x plus h minus 2, if I'm not wrong, x plus h minus 2 times 2x plus 3. Okay, so here I have 2x plus 3 minus, and then 2x plus 2h plus 3 times x minus 2. So I have to rewrite this up here. So I have basically x minus 2 times 2x plus 2h plus 3 minus 2x plus 3 times x plus h minus 2 minus 2, and divide that by h as h tends to 0. Okay, and so we need to simplify this a little bit. Now to simplify this, you have, well, this is basically, let's simplify this a little bit. Let's see what we get. So so that is 2x squared, that is 2hx plus 3x minus 4x minus 4h minus 6 minus 2x squared, 2xh or 2hx, negative 4 plus 3x plus 3h minus 6, which is equal to 2x squared. 3x minus 4x is equal to negative x, and you have plus 2 times hx minus 4h minus 6, and over here you have 2hx, x, h, and so this is 2x squared plus 2hx plus 3x plus 3h, negative 10, and then negative multiplied by this whole thing gives us negative 2x squared, negative 2hx, negative 3x, negative 3h plus 10. And so you will get negative x, negative 3x is negative 4x, negative 4h, negative 3h is negative 7h, and 10 minus 6 is equal to 4. And how do I simplify this thing now? This is equal to negative 4x if I'm not wrong. Somehow all of this, x plus h minus 2, x minus 2, h, and all of this will cancel out to give you a negative 7 only in the denominator. Let me do this part again because I might have made a mistake over here. This is 2x squared. This is 2x squared. 2x squared plus 2 times hx plus 3 times x, and then negative 4 times x, negative 4 times x, negative 4 times h, negative 6 and minus 2x squared plus 2 times hx 2 times 2 times hx minus 4 times x minus 4 times x plus 3 times x plus 3 times h minus 6. So that is 2x squared minus x plus 2 times hx minus 4 times h minus 6. Now here you have 2x squared plus 2hx, and here you have negative 4x plus 3x is negative x plus 3 times h minus 6. Multiply the negative sign by this, you'll get negative 2x squared, negative 2hx plus x minus 3h plus 6. And so these two will cancel out. Negative x, positive x will cancel out. These two will cancel out. And you have these two will cancel out. And so you have negative 3h and negative 4h, which is negative 7h. That's where I made a mistake. That is negative 7h. So then I can write this as the limit of basically negative 7h. And then you can bring this to the denominator and write it as x plus h minus 2 times x minus 2 times h. And then h and h you can cancel out as h tends to 0. And that is equal to, as h tends to 0, you will get negative 7 over x minus 2 times x minus 2, which is equal to negative 7 over x minus 2 whole squared. And again, you can see that the derivative of f of x is again not defined at x is equal to 2. Okay, the derivative of x is not defined at x is equal to 2. So then what that means is that the derivative of, when your f of x is equal to basically 2x plus 3 over x minus 2, then f prime of x is equal to negative 7 over x minus 2 whole squared. And of course you can do this using that quotient rule as well, meaning that u divided by v whole prime is the same thing as basically, what was that? U prime times v minus uv prime divided by v squared, and then you could take this as u, take this as v, and then you can write u divided by v whole prime is equal to basically u prime, which is equal to 2 times, for example, x minus 2 minus 2x plus 3 times v prime, which is equal to 1 over the denominator whole squared, which is x minus 2 whole squared. And I suppose if you simplify this, you will get this thing over here, meaning that if you write 2x minus 4 minus 2x minus 3 Then these two will cancel out. You'll get negative 7 over here, and you'll get x minus 2 whole squared over here, which is basically what we got over here. Okay. Well, okay, fair enough. Okay, so now suppose that you have another function like f of x is equal to x plus 1 divided by x. So about this function, again, this function is basically f of x is not defined at x is equal to 0, because if you put x is equal to 0, then this would be undefined. This 1 divided by 0 would be undefined. Now, based on the first principle, to find the derivative of this function, you know that f prime of x, which is equal to d by dx of f of x, is equal to the limit of f of x plus h minus f of x over h as h tends to 0. Now f of x plus h is equal to basically x plus h plus 1 over x plus h. This is x plus h, because wherever you see an x, you instead of x you have to put x plus h. So then f prime of x is equal to the limit of basically x plus h plus 1 divided by x plus h minus f of x, which is minus negative x negative 1 over x over h as h tends to 0. So then these two will cancel out, and so you have h plus 1 over x plus h minus 1 over x. So if you write this as the limit of, let me first calculate this over here. So if you have x plus 1 over x plus h minus 1 over x is equal to x plus h times x. So you have h times x plus h plus basically x minus x plus h, which is equal to hx times x plus h, and these two will cancel out. What did we do here? Minus x plus h, right? So there over here we get negative x, negative h. So x and negative x will cancel out. So you get only negative h over here. And then you have x plus h times x. So I can write this as h times x plus h minus 1 over x plus h times x. And now if I write this as this, basically this divided by h would be equal to, so a divided by b divided by c is equal to a divided by b times 1 by c. So you would write this as a times a over b times c, which means that this divided by this times this, and then you can cancel the h's out. Okay, so then I write this as the limit of basically h times x times x plus h minus 1 over x plus h times x divided by h as h tends to 0. And so as you can see here, I mean, the only thing that, I mean, it's just pure algebra, right? And basically over here, if you haven't learned your algebra well, then you will get into trouble here, meaning that what I have found personally in mathematics is that if you want to be able to understand, for example, the mathematics that you have in class 11 and class 12, which is basically the same thing as you study in the first year university, second year university, and so on and so forth. First year university, second year university is usually the same thing that you read in class 11 and class 12. These are pretty advanced topics that you study in class 11 and 12, and then in the first and the second year of university you usually study them again, and then they make some changes to the concepts, but it's basically the same thing. And so you can see that what we are doing here is practically the first or the second year of a university course, some engineering course or something like that. And if you want to be able to understand this, you do need to start at class 6, 7, 8, 9, 10, and well, these you need to understand well. If you have problems in these classes, then you will run into many types of problems in these two books. So if you have any problems over here, you need to go back and take care of them. So now what I can do is that I can write this as the limit of, basically, again, if I take this as a divided by b and divide that by c, I can write this as a divided by b times c, times 1 divided by c, the reciprocal of this, times 1 divided by c, which is the same thing as a over b times c, meaning that you write this in the numerator. So h times, for example, x times x plus h minus 1, you write this in the numerator, and these two you write in the denominator. H times x plus h, and then you can cancel these two out as h tends to 0, and so as h tends to 0, over here in the numerator you will get basically x squared minus 1, and over here you will get x squared. And again, you can see that this function, which is the derivative of f of x, this is f prime of x, is again not defined at x is equal to 0. And again, you can use the quotient rule in order to calculate this, meaning that if you have, for example, f of x is equal to x plus 1 over x, you can write this as x times x, and this is x squared plus 1. You can write your f of x as this. And then we said that u divided by v whole prime is equal to u prime times v minus uv prime over v squared. So then if you have this function over here, which is basically the function that we started with, then f prime of x would be equal to u prime, which is the derivative of this, which is 2x, times this function x minus this function x squared plus 1 times the derivative of this, which is equal to 1, over this function whole squared. And that is equal to basically 2x squared minus x squared minus 1 and over x squared, which is equal to x squared minus 1 over x squared, which is the same thing that we got over here. So of course these are easier, but whenever you do need to use the first principle, of course then you use the first principle and use the limit and everything to calculate the derivative of your function. Okay, so okay. Now what we want to do next is find the derivative of f of x from the first principle, where, for example, f of x is sine x plus cos x. If your f of x is equal to, for example, sine x plus cos x, so using the first principle, you know that again, you know that basically f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. Now over here, basically f of x plus h is equal to sine of h x plus h plus cos of x plus h. So then I can write this as, then I can write the f prime of x as the limit of f of x plus h, which is this thing over here, sine of x plus h plus cos of x plus h minus f of x, which is minus sine x minus cos x. The negative is going to be multiplied by both terms, so two negative terms over here, over h as h tends to 0. Now now we do need to do, I think we need to do basically we do need to take care of this in 2 steps, I suppose, or in 3 steps. Let's see. Okay, so now to simplify this thing, let's see what happens if we, so basically what we can do, basically the formulas that we have are all about cos and sine. So for example, I have sine x minus sine y. I have sine x minus sine y. And that is equal to 2 times cos, for example, x plus y divided by 2 times sine of x minus y divided by 2. Okay, so if I use, for example, this formula for this and this part, I will get, instead of these two, I will get this product over here. And I can write this as basically that plus cos. Okay, so let's do it. Let's see what happens actually. So if I write the limit of basically instead of these two, I'm going to write 2 times cos x plus y divided by 2, which is x plus h, x plus h plus x divided by 2, which is 2x plus h divided by 2. 2x plus h divided by 2. And then sine of x minus y divided by 2. So x minus y divided by 2 would be x plus h minus x divided by 2, which is equal to h divided by 2. So that is h divided by 2. Okay. Now, the next part over here is basically cos x minus cos y. Cos x minus cos y, which is equal to negative 2 sine x plus y divided by 2 times sine of x minus y divided by 2. Okay, so let's see what we can do with this. So I can write negative 2 times, and remember that this is basically, if I take these two as, for example, whatever you want to take that is that you can write, for example, you can write this numerator as, for example, sine x plus h minus sine x, which is basically this thing over here, and then you can write it plus cos of x plus h minus cos of x. So you have a positive sign over here, and so I use the positive sign, but I mean I'm supposed to write the positive sign over here and write whatever I have over here, but well, positive into negative is positive. Otherwise, well, I don't want to confuse you, but you need to be careful about this. Anyway, I write this as negative 2 sine basically x plus y divided by 2, which is again it's basically this one and this one over here. So you have x plus y divided by 2 is x plus h. X plus h plus x divided by 2 is 2x plus h. So negative 2 sine of 2x plus h divided by 2 times sine of x minus y divided by 2, which is x plus h minus x divided by 2, which is again h divided by 2. So, and then you need to basically divide this by h. Divide this by h as h tends to 0. Now, so here you have 2 times cos 2x plus h divided by 2 sine h divided by 2, and sine h divided by 2 sine 2x plus h divided by 2. So I can take a 2 times sine h divided by 2 out. So let's see what happens if I do that. If I take from the numerator, if I take a 2 times sine h divided by 2 out, what happens is that I will get cos of 2x plus h divided by 2 minus minus sine 2x plus h divided by 2. Okay, now let's see if we have a formula for this. What we have basically, this is the same angle as this, so this you can call this, for example, cos x minus sine x. I think there is something here that we can use. No, I don't think so. No, I don't think so. So I'm going to just simply write it as, I'm just going to call this, for example, cos x minus sine y, for example. But of course, x and y are the same angles. So then cos x minus cos y. So you know that cos x minus sine y is equal to, which I don't really have it. Which I don't really have it. Or probably cos x plus sine x or something like that. No. So let's see how they have solved this problem. Let's see. So you see what they have done over here is that they have it seems that there is no way to solve this problem this way. So what they have done is that they have used the formula, for example, sine x plus y, to expand this thing over here, or basically cos x plus y, to expand this one over here, and then they have done the rest of the thing. So I'm going to write this as, I'm going to delete all of this over here, or erase them. And what I'm going to do is just simply, so this is basically the very beginning. So I'm going to use these as well. I need them. So then basically you know that sine x plus y, you know that sine x plus y is equal to, in the beginning over here, sine x plus y is sine x cos y, equal to sine x cos y plus cos x sine y. And cos x plus y is equal to cos x cos y. Cos x plus y is equal to cos x cos y minus sin x sin y. So what you need to do here is that you can write this as the limit of basically sine x plus h is sine x cos h plus cos x sine h, and cos x plus h is equal to cos x cos h plus cos x cos h minus sine x sine h minus sine x minus cos x over h as h tends to 0. I suppose that's the way that they have written it. And then sin x cos h plus cos x sin h plus cos x cos h minus sin x sin h minus sin x minus cos h over h. Okay. So now you need to take some things out of these 2 by 2. Meaning that from sin h you can take out from here you have sin h and here you have sin h. So you can take it out. The limit of basically sin h times basically so cos x, for example, minus sin x. So these two are taken care of. Then you have sin x over here and over here. So you can write, for example, plus sin x, and I'm looking at the solution because I want to do it the way that they have done. Sin x times cos h minus 1. And then you have, so these two are taken care of. Then over here you have cos x, I write cos x over here times, for example, cos h minus 1. And divide that by h as h tends to 0. Then you have cos x minus sin x, cos h minus 1, and then you can take then they have written this as sin x by, okay, so you could write this as the limit of basically, or you can basically, let me first do this step over here. You can write this as the limit of x tends to 0, and then you can write this as, for example, sin h times cos x minus sin x over h, okay, plus sin x times cos h minus 1 over h plus cos x times cos h minus 1 over h, and then I have written this as, so then you can write this as the limit of h tends to 0 h tends to 0 of sin h over h times, for example, times cos x minus sin x plus over here you can write this as sin x times cos h minus 1 over h plus cos x times cos h minus 1 over h. Okay, and then you can write this as the limit of h tends to 0 of this thing over here, basically sine h over h times cos x minus sine x plus the limit of h tends to 0 of sine x times cos h minus 1 over h plus the limit of cos x times cos h minus 1 over h. So then, of course, you know that you can write this, for example, this part, you can write it as the limit of, for example, sine h over h as h tends to 0 times the limit of, for example, cos x minus sine x as h tends to 0 plus so on and so forth, thus in the same way. Now, the only important thing is to simplify this thing. So I know that, for example, the limit of sine h by h when h tends to 0 is equal to 1. And then you're left with the limit of cos x minus sine x as h tends to 0. So that would simply be cos x minus sine x. So over here, for this first part, you will get cos x minus sine x. Cos x minus sine x. Over here, this is supposed to be something that we have done before, but I don't remember that such a thing. I don't really know what this thing is. The limit of sine x times cos h minus 1 over h. Let me go back and take a look at these things and see if there is something that I'm missing here. Okay, so basically in some video that we did pretty long time ago, we said that the limit of, and I had forgotten that, so we said that the limit of, basically, write it somewhere else, we said that the limit of 1 minus cos x over x when x tends to 0 is equal to 0. And we proved this. So this works actually. So what that means is that now over here what I have, instead of 1 minus cos x over x, I have cos x minus 1 over x. So what I can do is that I can multiply a negative instead of, meaning that I can, instead of basically the limit of, basically, now you can just let's concentrate, for example, on this part for now, because you know that the limit of, for example, I can write the limit of sine x times cos h, for example, minus 1 over h as h tends to 0. I can write it as the limit of sine x, for example, as h tends to 0 times the limit of, for example, cos h minus 1 as over h as h tends to 0. Okay. Now, when h tends to 0, the limit of sine x is going to be equal to sine x. This doesn't have anything to do with h, so it's equal to sine x. Now, the limit of cos h minus 1 over 1, I can write it as the negative of the limit of h tends to 0 of basically negative of cos h minus 1. I multiply a negative sign by the numerator, and then I multiply a negative sign over here outside the limit, so they cancel each other out over h. So now what that means is that this is now equal to times the limit of basically instead of cos h minus 1, this becomes 1 minus cos h over h as h tends to 0. And now that is exactly this thing over here, which basically is equal to 0. So this is negative 0. So now this becomes sine x times negative 0, which is equal to 0. And by the same logic, then this is also equal to 0. So this whole thing goes to 0. This whole thing goes to 0. And so the limit becomes, the derivative becomes cos x minus sine x. So let me go back here. I don't know where I was. Algebra 1. What is that? Okay, so I have somewhere over here. X times cos x plus sine x. I don't know where the x comes from. There's an x. There's supposed to be an x somewhere over here. Maybe it's the question or something. Sine x plus cos x. Sine x plus h. Is cos x plus h. Sine x plus cos x. Sine x plus equal to sine h times number 2 x times sine. Oh, okay. Cos x minus sine x is the right answer. Cos x minus sine x is the right answer. I was looking at the solution for the second problem. Okay, so that's basically, for example, how you solve this kind of problem. So remember that the limit of 1 minus cos x over x when x tends to 0 is equal to 0, and the limit of sine x over x when x tends to 0 is equal to 1, I suppose. These two are basically the two limits that are important. Okay, so the next question that we have is basically we have a function x times sine x. We have a function over here which is x times f of x is equal to x times sine x, and we want to find the derivative of this using the first principle. We will do that in the next video. See you in the next video.